Hello and welcome to section 7.2 on module 7. Okay, so now you have a basic understanding of how DHCP version 4 works and how it can make your job a bit easier. Now we're going to move on to part 2 of module 7 and have a look at configuring a Cisco wireless router to function as a DHCP version 4 server. Okay, that's the main objective of this lesson. Cisco router running Cisco iOS software can be configured as a DHCP version 4 server. And what the router does is, once it's configured as a DHCP version 4 server, it starts to assign and manage IPv4 addresses from specific or specified address pools within the router to any DHCP version 4 enabled client. Okay, so here you will see in this packet trace a file. By the way, I've uploaded this file together with this lesson. So as you're watching this video, you can download the file and follow along as I demonstrate different aspects of configuring a Cisco iOS DHCP version 4 server. Okay, so here you see R1. We're going to configure R1 as our DHCP version 4 server. And there are two networks, two local area networks you can see. On your left hand side, you can see 10.0, 192.168.10.0/24. On your right hand side is a separate network, that's 192.168.11.0. So there are two different subnets, the 10.0 subnet and the 11.0 subnet. So we're going to create a pool of addresses specifically for the 10.0 network. Okay, so when you're configuring a DHCP version 4 server, there are at least three steps, okay, three basic steps that you need to follow to configure a Cisco iOS DHCP version 4 server. Basically, the first thing you will need to do is be specific about what IP addresses you need to exclude. Okay, so excluding IPv4 addresses. Now, if you look at our network here, there are several addresses I want to exclude. Since we're trying to create a pool on this side, a pool of addresses specifically for this LAN, we want to exclude the IP address that's on this gateway, the default gateway address. And maybe, let's say, we want to exclude 10.1 up to 10.10, let's say, for example. Okay, so in this lesson, we want to exclude 192.168.10.1 up to, let's say, 10. Okay, 10.10. Okay, so we want to exclude these addresses. Okay, why do we have to exclude them? Now, when we are excluding these addresses, when we define the pool, the DHCP server is not going to use any of those addresses we specify that are excluded. Okay, so a single address or a range of addresses can be excluded, basically by specifying which address you can start from. You see, IP DHCP excluded address, low address, and the high address. So here our lowest address will be 10.1, our highest address will be 10.10. What that means is that the DHCP server is not going to list out 10.1 all the way up to 10.10. After that, 10.11, 12, 13, 14 up to the last address, it will start to list out. Okay, so let's go ahead to R1 and then we're going to configure our DHCP version 4 server. By the way, do you note that for this network, we haven't configured two interfaces, the one pointing to switch 1 and the one pointing to switch 2. Okay, so let's use 10.1 and 11.1 for the two different networks as the default gateway. So the first thing I'd like to do here is just set the host name to R1. Okay, We'll leave out all the other basic config settings just for the purpose of this video. If you want, you can go ahead and configure all the other basic configurations that are required. Just go straight to int g000 IP add, and I'll give the address 192.168.10.1. Subnet mask is /24, so 255.255.255.0. Make sure to turn the interface on, no shut. I'll just put in a description, link to S1. Okay, exit, and I'll configure the interface on the right hand side. Okay, so int g001, yep, IP address 192.168.11.1 /24 subnet mask. Make sure to do a no shut, turn the interface on, and that's basically it. Okay, so do a copy run start or WR to write the running config to memory, and let's just make sure that configurations are okay. We can see green, that's fine. Okay, so let's go ahead and follow step 1 to configure, start the configuration process for the DHCPv4 server, and by doing step 1, which is to exclude addresses. So notice we begin by using IPDHCP. Okay, you begin off IPDHCP and then just put a question mark. Okay, so you can see the first parameter required is excluded address. Okay, so we want our low address to be 192.168.10.1. we don't want to use that address. We don't want to use 10.2, 10.3 all the way up to 192.168.10.10. Okay, so those are the parameters I want to specify. The low address, okay, low address is 10.1 and the high address is 10.10. so notice it's a range of addresses. Okay, so you can exclude a range of addresses. You can even exclude a single address. Okay, so let's go ahead and hit enter. We'll try that again, and let's exclude a single address, 192.168.10. Let's use the last address, 254. You see, you can exclude a single address as well as a range of addresses. Now typically when you're excluding addresses, the reason why you have to do that is these excluded addresses are normally addresses that you assign to routers, servers, printers and other devices that have been or you planning to manually configure those addresses on. Okay, that's where you start excluding addresses. Okay, so that's the reason why you exclude address. So what's the next step? Now we have to define a DHCPv4 pool name. Okay, so we have to create a pool name. So we'll call this our LAN1. Okay, so let's go ahead. We'll call this the LAN1. So I'm going to go ahead and type IP DHCP. Just put a question mark again. Notice the second parameter we will use here is pool. Okay, so we type in pool. If I leave a space and put question mark, it's asking me to type the pool name. Okay, so I'll use pool LAN pool 1. Okay, so that's the LAN1 pool of addresses. So that's the name. Okay, hit enter. The next thing we will need to do is specify the pool of addresses now. That's step number 3. Okay, so I put a question mark in there to show you the different parameters we can be able to configure at this stage of configurations. And notice the prompt also changes to DHCP-config. Okay, so now we can specify a default router here. We can specify a DNS server. There are several things we can specify here. So we will go ahead and configure the DHCP pool, but we'll also address a few other parameters as well. The address pool default gateway, we'll need to configure that. So we'll have to use the network statement here to define the range of available addresses. And then we're going to use the default router command to the default router, the first one, to define the default gateway router. Okay, so you can see from this point here, when we are setting this R1 as a DHCP version 4 server, the pool is specific for this LAN. So we want to tell this router, for this LAN, that's the name of the pool. We're going to specify a pool of addresses using network. We're going to specify which device or which server it has to look to for DNS name resolutions. And we'll have to also specify which router is going to be the default router. Okay, which router is going to be the default router. Basically, that's defining the default gateway. So in this case, it will be the interface G000 IP address. Okay, so the first things first we need to do here is specify a pool of addresses. Now, when we are specifying a pool of addresses, notice we've excluded 10.1 up to 10.10 already. Okay. Now, when we specify the pool of addresses, we've created a pool name. We just want to say here that it's going to come from this network 192.168.10.0. Okay, that's the network. Okay, so notice when we're using the network command, we specify the network number or the network ID as well as the subnet mask 255.255.255.0. Okay, hit enter. Okay, so I've just created a network that this pool is going to list IP addresses from. However, it will exclude this range of addresses, including this single address. Okay? I hope you get that. Okay, so that's configuring the DHCP pool. Now, there are other information that we need to also add in so that the router is going to not only just list out an IP address, it will also list out other network config options, including the default gateway information. So let's put in default router, and default router will be 192.168.10.1. hit enter. We need to specify a DNS server as well. Now I'll show you why we need the DNS server 192.168. DNS server, we're going to use 11.6. Why 11.6? That's our DNS server. Okay, that is going to be our DNS server, and we're going to assign this address 11.6. That's the reason why we're telling R1 as a DHCP server to give this information to clients requesting for IP addresses. So not just an IP address, it will give the default gateway info, it will also give the DNS server information. Okay, the next thing we need to include here is also a domain name. Now, why do we need a domain name? Basically, that domain name is going to be used within that particular network here. Okay, so we go domain, domain name. Okay, just call that corona.com. Okay, domain name corona.com. We are in the Corona well now, so let's use corona.com. And I think that's about it we can do here. We'll leave out the other options. Let's end this, do a WR to save the configurations. Okay, so I'll close that, and that's basically done on part 1, configuring DHCP server. So notice it's pretty much straightforward. If I go to PC1 and I click on, I just go static, it was on DHCP already. Go DHCP, it starts requesting, and there you are. Notice when it receives an IP address, that IP address cannot be within the excluded range. Can you see that? It's 10.11. It will go 10.12, 10.13, 10.14 up until 10.253. In addition to the IP address and subnet mask, notice default gateway information is added. DNS server information is also added. Okay, so that's good. That's one way of verifying that DHCP version 4 server has been configured. Let me just remove this information here. Okay, so the next thing we need to do now is to verify. Okay, so we can either verify from the client's end by going to ipconfig and setting it to DHCP to verify whether it will receive an IP address. If it fails, then something is wrong with the configuration. Let's try verify from the router. So there are a number of configs that we can, commands rather, that we can use here if we are verifying the configurations of DHCP. Okay, so let's use let's do a show run. Now show run is going to show us a lot of information, so let's use the pipe parameter, and we only want to filter out the sections on DHCP. So if we hit enter there, notice we've configured DHCP already. So this verification, this command displays the DHCPv4 commands configured on the router. So notice what we've used here. Okay, this is what we've done. First step. Second step, we created a pool, and then we started configuring the various options of DHCP. Okay, so show run pipe section DHCP. DHCP shows us the commands that were configured on the router. What about the IP addresses that were leased out? How do we tell from the router itself? So do a show IP DHCP. Just put a question mark in there. Let's see the list of addresses, parameters that we can use. Okay, let's try binding. See binding, that shows us the address bindings. Okay, hold on, not bindings, binding. Okay, so notice it has given out an IP address, and that's the IP address, that's the binding. Do you notice something here? It maps a layer 3 address to a layer 2 address. You see, layer 3 to layer 2 mapping. See, that's what DHCP does. It maps the IP address to the MAC address. See, it maps the IP address to the MAC address. Okay, so let's try the next one. There's another command I put down here. Show IP DHCP server statistics. As the name implies, it's supposed to display count information regarding the number of DHCP messages that have been sent. Let's put a question mark there. You can't see anything on server. Okay, so I don't think that's going to work. Let's just try and confirm that. Yep, it does not pick up server, nor does it recognize statistics because it's not listed anywhere here. Okay, so let's leave that part out. Let's leave that command out. Packet tracer has some limitations, so this could be one of them in terms of DHCP. Okay, so we've just configured DHCP server. We've excluded addresses, a range of addresses. We've excluded a single address. We've created a pool name. We've configured a subnet from which the pool can lease out IP addresses from. We've added the default router information, the DNS server information, including the domain name as well. Notice I didn't put in lease. I didn't put in lease. Let's just go and check this out. We missed that part. So conft ipdhcp, go pool and len pool 1. Okay, that's the pool we created earlier on. I'll just put a question mark. Is there anything on lease here? Okay, so there's no lease option here. There's no there where we can negate a command or set it to its defaults. We'll use that later when we disable the DHCP service. Let's try and use IP DHCP, let's go option. Oh, it's not recognizing option. Hold on, I should not be typing that. Just type option only. Option DHCP option code, or no, we don't need that here. Okay, so let's go out of this. Let's try do okay, there's no list information we can be able to configure here. We are not able to configure lists in the iOS here. Okay, so we can leave that out, but basically what the list does, I think you should know by now that it gives a time frame on which the address can be used up to the end of the time frame. Then it will either renew or reassign that same IP address back to the same client again. So that's the purpose of that command, but we'll just leave that out. Let's go to step number 3 and try to disable the iOS DHCP version 4 server here. Now, why do we need to disable that? Now, there are some security issues that come with configuring a router as a DHCP version 4 server. Remember that for every application we open, there's a possibility of you expanding the vulnerability surface of a device. So if we are not using the service, the DHCP version 4 service, there's no point in it being active. So we need to disable it. Okay, so here's what you do. You use the no service DHCP to disable that. Okay, so if you use a no service DHCP, it disables the iOS DHCPv4 server. To re-enable it, service DHCP. Okay, we won't disable it yet. I want to give you a scenario, and that will bring me to point number 4 on DHCP version 4 relay. The purpose of the relay command, IP DHCP relay, and why it needs to be used. Now think about it this way: in a small office, home office network, a SOHO environment, you really don't need a fully fledged standalone DNS server. Okay, DHCP server. You can use your existing router as a DHCP server. Now, when you go to large, complex, hierarchical networks, enterprise networks, these enterprise servers will be usually located centrally at the core of the network, and these servers may provide DHCP, DNS, as is in this case. We will check out the purpose of DNS here. We'll try verify it. They might provide TFTP, FTP, or other services, email services for the network. And network clients like PC1 and PC2, these devices try to attempt, to connect to a DHCP server, and they are not normally on the same subnet as those servers. You see, for example, PC1 is not on the same subnet as DNS server. You see, in cases where you have complex hierarchical networks where clients can be in many different subnets apart from the servers, they will have to send out, remember, the DHCP requests normally go out as broadcast messages, and by now we should know that routers do not forward broadcast messages, which means that if PC1 were to communicate with DNS server here, or if this was a DHCP server, and then we had PC1 here on this end trying to communicate with the DNS server, it will send out a DHCP request. But as soon as the request broadcast message, the request is a broadcast message, reaches R1 will just simply drop it. It will not forward it on because it does not forward broadcast messages. So that's where we have DHCP relay playing a very important role. So this command is very important, DHCP IP DHCP relay. I'll show you why DHCP relay is important, and then we'll look at the IP helper address. Let's close off DHCP service first. Let's disable it. So we'll use a no service DHCP. So we go no service DHCP. Okay, so we've just disabled that. Okay, to verify, go to PC1, place it on static, DHCP again. It starts requesting IP address. Failed. Okay. Now notice we have disabled DHCP services on R1. Let's go to the DNS server. Click on that. Go to services and go to DHCP. So we'll use version 4. Okay, it's off at the moment. Okay, it's off at the moment. Let's turn that on. Okay, let's turn this service on. And we already have an existing pool of addresses. No default gateway information, no DNS server, but starting IP address is 11.0. Okay, 11.0. Let's keep that 11.0. Okay, let's turn the service on and we close that. Okay, if I go back here and I click here, notice it's never going to receive anything because it will be sending out a DHCP request, but as soon as the request hits R1, it's dropped. Let's check PC2. Let's remove it from static and go to DHCP. Yep, see, it picked up an IP address. Again, notice why that happened, because PC2 is in the same subnet as the DNS server. When you look at PC1 is on a different subnet. So this is where we now need to use this command, IP-DHCP relay. Okay, let's go to R1. Let's use IP-DHCP, leave a space, question mark. Can you see relay is there? Okay, so put relay, put a question mark again, relay information. Let's just hit enter, incomplete. So we have to put in IP-DHCP relay information. Okay, hit enter, still incomplete. Leave a space, put question mark. Okay, it's asking for trust all. Okay, so trust all DHCP request. Okay, hit enter there. So IP-DHCP relay information trust all. Okay, so IP-DHCP relay is the basic command, but you can add this all so that received DHCP packets will contain the necessary information that's required. Okay, so now we've done the relay there. Let's go back to PC1, ipconfig to a static, DHCP again. Let's wait and see what happens. Whether it picks up. Okay, it failed again. Okay, so notice there's still something wrong here. Although we used IP-DHCP relay, we can still see that PC1 is not able to forward. Okay, it's looking for a DHCPv4 server. When we set it to DHCP, it's sending out DHCP request, but R1 is not forwarding broadcast between the network. Okay, so either the DNS, the DHCP server has to be located in the same subnet, or we need to configure a relay. Now you've just noticed that we've created a relay here, but unfortunately it didn't send out that information back. Okay, it didn't send that information back. If we go try it a second time again, static DHCP. Okay, so it's sending out a request, DHCP request. Again, the DHCP failed, and it hasn't given an IP address, it hasn't forwarded that information. So now let's try use IP helper address. Okay, let's try use the IP helper address. Now why do we have to use the IP helper address? When R1 has been configured, okay, as a DHCP version 4 relay agent, that's what we've just done. It will accept broadcast requests for DHCP version 4 services, okay, from clients within that subnet, and then forward those requests as unicast to the IPv4 address of the DNS server. But in this case, we haven't told R1 who is the DHCP server in this case. That's where the second command comes in now, IP helper address. Okay, so let's go to R1. Let's use IP helper address. Leave a space question mark. Oh, IP helper. Let's just put IP question mark. Okay, let's check the different commands available. Okay, we don't have an IP helper address. Okay, notice that we don't have an IP helper address. Okay, this should cause R1 to relay the DHCP version 4 broadcast to the server, but notice we are not able to find it here. Now, why we are not able to find it here is, if we go back to our network, we are receiving requests from here, okay, from this interface, but those requests need to be forwarded out of which interface? This interface. So let's try go to that interface. Okay, so we go int G001, and let's just put IP question mark, and there we are. Okay, helper address. Okay, so these are all UDP broadcasts that need to be forwarded. So IP helper address, and we need to point to this server. Okay, so what we're telling the router is this: anytime you receive any UDP broadcast messages, okay, DHCP broadcasts are part of UDP. When you receive them, you're going to forward them to this server. Now just take note, put this in here so that you can see the IP helper address command not only forwards just DHCP only, it also forwards other UDP services as well. See time, TACAX as well, DNS, TFTP, this is for security, for authentication, NetBIOS name service, NetBIOS datagram service, TFTP, and so on. Okay, so DNS is what we are looking at. DHCP is what we are looking at. So IP helper address, we just need to point to the address of the server. So 192.168.11.6. Hit enter, and let's close that. Let's go to PC1 IP helper. I'll set it to static again, and let's go DHCP. Fingers crossed, this should work. Oh, it failed again. It failed again. Okay, it failed again. Okay, something is wrong here. Did you notice, if I go back here, did I use the right interface? Shouldn't it be this interface, int G000, okay? Because we are receiving the broadcast from this end, not from that end, from this end. Okay, so IP helper, IP helper address 192.168.11.6. Enter. Okay, go back to PC1 and go static, set it to DHCP again. Again, fingers crossed, it's requesting, it's doing the DORA process, failed. Okay, set it to static, try again. Okay, it failed again. Okay, so I'll go to R1. Let me go to exit, int G001, no IP helper, no IP helper address. Let's just, no IP helper address 192.168.11.6. Let's just finish it off from close the helper from that interface, allow it only on this interface. Let's try this again. Don't worry, this is going to work. Okay, let's ask it to request again, DORA process, and it fails again. Let me go back to the DNS server, desktop, ipconfig. Okay, default gateway is 11.1, correct. Yep, all good on the server side. Let's check here. Yes, it has received 11.2. Okay, I see why it's not picking up an address. Let's try that again. Okay, the address pool of addresses, the pool of addresses, let's try a different pool. Server pool 2. Okay, and the default gateway, I'll leave the server pool as it is, but the default gateway should be 192.168.11.1. DNS server should be 192.168.11.6. okay, so we save that. Okay, it's on. Close that. Let's go and ask request. Okay, one of the reasons why this could not be working is because it's on a separate subnet. Okay, we already have the 11.0 here. So if I click here, if I go back, notice it didn't assign a default gateway. If I go static and I request again, it will put in the default gateway information because I just did that on the DNS server here. So that's understandable. Let's put in a subnet. That's put in the appropriate subnet. So let's create pool number 2, and we say 10.1 is the default gateway. DNS server will remain as 11.6, and it will start IP address will be 10.0. Yep, and let's leave everything else as it is. Okay, add that. Okay, let's see how this works out. We set it. Oh yeah, it picked up. Okay, so we just realized, notice we have two separate subnets. Okay, see, we had the 10.0 subnet. Okay, and then we had the 11.0 subnet. Okay, so when we specify two separate pools, now we are able to have DHCP services being IP addresses being leased out to its appropriate networks or subnets. Okay, so that's basically the purpose of DHCP version 4 relay commands. Okay, so we have the IP DHCP relay. We also have the IP helper address. So that should help you understand the purpose of why you have to configure an iOS as a DHCP version 4 server. There are situations where you need to do that. Okay, you need to do that. Not all the time you will have to configure a router as a DHCP version 4 server, especially in a large complex hierarchical network, large enterprise network. You might have dedicated DHCP servers, but in this case we can use the DHCP, we can use a router as a DHCP version 4 server by configuring the iOS. Okay, let me just summarize this by testing the DNS services. So I'll go to DNS, I'll go to the DNS server, click on services, DNS, just make sure DNS is on. We'll just do this for the last, for final check, verification, and then we can save that. I'll create a website as an area code, www.corona.com, and my web server is this same machine, so it's going to be 192.168.11.6. I'll add that. So DNS service is on, HTTP service must be on. I'll go to PC1 and I'll click on the web browser. Okay, the web browser is here. So click on the web browser, www.corona.com, and there you are. Okay, so that verifies that when HTTP traffic is coming from here to here, because DNS information is already configured inside through DHCP, it has given that information, DNS 11.6. When I type in the browser, when I type in www.corona.com, what happens is that the mapping, okay, the mapping of the IP address to the name is done by the DNS server. So DNS domain name services does the resolution. Okay, it resolves IP addresses. Instead of typing in here 192.168.11.6, I just type the name. Okay, so it's a job of the DNS server to resolve the name to the IP address. Okay, so welcome to coronavirus. Well, stay safe, always wash your hands with soap and water, keep a distance of a meter or more.